Hello everyone, in this video we are going to understand about the Gauss elimination method. So we will see a working example to understand this method, and after that we will see that how we can implement this method using a C program. So let's start. The Gauss elimination method is a method which can help us to find the solution of group of linear equations, or you can say the simultaneous linear equation. And this method is also known as elementary row transformation method. So we will see later in the video that why this method is known as elementary row transformation. So here we should know what are linear equations. So in simple term we can say linear equations are those equations which when drawn graphically they form a straight line. For example, this function fx, it is showing a equation, and this function is actually showing a linear equation because this line is actually a straight line. In the similar manner, this fx is also showing a linear equation. So you can simply say, for example, you have x plus 2y equal to 0. So here this equation when shown graphically, it will draw a straight line on the graph. And the other property of the linear equation is the power of the variables in the linear equation is always 1. So here this power is 1 and the power of y is also 1. So all the power should be 1 in case of linear equation. So the next question can be, what are non-linear equation? So non-linear equation are those equations in which the power of the variables is greater than 1. That is, it can be 2, 3 or so on. So for example, you have, let's say, quadratic equation. So this equation is a non-linear equation because if we draw the graph of this equation, then it will be something like parabola, or you can say some curved lines. So this fx or this equation is a non-linear equation. So Gauss elimination method is applied only for the linear equations. Now next question is, what does it mean? System of simultaneous linear equation. So when we say system of linear equation, it means the collection of many linear equations. For example, here we have these two linear equations. So this collection of these two linear equations is forming a system of linear equation, or you can say group of linear equations. And both these equations have the same set of variables. For example, this has x and y. So second equation also has the x and y. It may have that second equation can only be like minus x equal to 1 because this will be equivalent to x plus 0y equal to 1. So in this way, there can be many linear equations, and the group of those linear equations will be called as system of linear equation or system of simultaneous linear equations. Now what does it mean that we have to find the solutions of system of linear equations? It means, for example, we have these two equations. So to find the solution of these linear equations, it means we have to find the values of the unknowns. That is, we have to find the value of x and y such that when these x and y values are put in both these equations, then those x and y should satisfy both these equations. That means the x and y value, when they are kept in this first equation, then this side should give us the answer as 2. So that 2 equal to 2. And the same set of values of x and y, when those are put in this x and y, then we should get 1 from this left side. So that 1 is equal to 1. So this is the meaning of the finding the solution of simultaneous linear equations. So there are different methods to find the solutions of simultaneous linear equations. And those two methods are direct methods and indirect methods. So direct method are also known as exact method, and indirect method also known as iterative methods. Under direct methods, we have these methods. We have the Gauss elimination method, Gauss-Jordan method, and Krauss method. And under indirect method, we have the Gauss-Seidel, Gauss-Jacobi, and relaxation method. So in this video, we are going to understand about the Gauss elimination method. So now let's see a working example and understand that how this method can be applied on those systems of linear equations. For example, we have these set of linear equations, and we have to find the values of x, y, and z so that those can satisfy these group of linear equations. So to apply the Gauss elimination method, we have to follow some certain steps. And these are those steps. That is, we have to first convert these system of linear equations into a augmented matrix. Second step is we have to convert this augmented matrix into the upper triangular matrix. And how we can do that? By applying the row transformation or row transformation operations. And lastly, to find the values of x, y, and z, we have to apply the back substitution method. So what is meant by augmented matrix, upper triangular matrix? So let's see that. So first we have to convert these system of linear equations into the form of Ax equal to B, where A is a matrix, X is, you can say, a column vector, and B is also a column vector. So inside the array A, we have to write the coefficients of these x, y, and z. So here you can see we have the coefficient as 2, then 1, then 1. So we can write as 2, 1, 1. Then we have the coefficient as 3, 2, 3. So we can write 3, 2, 3. And then we have the coefficient as 1, 4, and 9. 1, 4, and 9. And this x represent the unknowns. So in these equations, what are the unknowns, or we can say what are the variables name? We have the x, y, and z. So we can write x, y, and z. And then here inside this b vector, we have to write these constants, that is 10, 18, and 16. So we have converted these group of equations in this Ax equal to b format. So actually these two formats are equivalent to each other. That is, if we multiply this A with X, we will get this form only. Now the augmented matrix is of form like A colon B. So what does it mean? So what augmented means? To join something to something. So what does it mean? We have to join the B vector to the A matrix. That means here we have write this A matrix, and now we can either put colon or we can put this straight line, whatever you want to do. Now here we have to write the B values. So B values are 10, 18, and 16. So this complete matrix is a augmented matrix. Now after that, in the second step, we have to convert this matrix into the upper triangular matrix. So what is upper triangular matrix? So upper triangular matrix is the matrix in which all the elements below the diagonal, that is all the elements below this ADF are all zeros. So here you can see this element is 0, this is 0, and this is 0. So this matrix is a upper triangular matrix. You have to take care that all the elements below this primary diagonal should be all zeros. So that means we have to convert this augmented matrix in such a way so that all the elements below this 2 to 9 should be zeros. And these elements can be anything, but these three elements should be zeros. So after we have changed our augmented matrix into the upper triangular matrix, we have to apply the back substitution method to find the values of x, y, and z. So let's see how we can apply all these steps to find the solution of this group of equations. So this is the same question. Now first I will convert these equations in the augmented matrix directly. So first I will write all the coefficients, that is 2, 1, 1, 3, 2, 3, and so on. And now I will put colon here, or you can put any other thing also like dash also. And then I will write 10, 18, 16. That is the B vector. Now this is my augmented matrix. So my first step is complete. Now what I have to do? I have to convert this augmented matrix into a upper triangular matrix. And how I will convert that? I will apply various row operations for that. And for upper triangular matrix, what is our motive? Our motive is we have to make this 3 as 0, this 1 as 0, and this 4 as 0. Then only all the elements below this 2 to 9 will be zeros. Now as I said, this 3 has to be made 0 and this 1 has to be made 0. So while we are making this 3 and 1 0, we will take the help of row number 1 for making these 3 and 1 zeros. In the similar manner, what I will do for 4, when I have to make this 4 as 0, I will take the help of row 2, that is this row. That is, I will take the help of this 2. So I have to apply some row operations on this matrix, and then I will get a new matrix. So let's start with this 3. And how we can make this 3 as 0 using this 2? That is, we can, let's say, write R2. That means this is row 1, this is row number 2, and this is row number 3. So when I am saying R2, that means I want to change the row number 2. That means this row. Now I will take the help of row 1. So what manipulations or what addition or subtraction should I do on this 3 with this 2 so that I can get answer as 0 at this position. So let's say if I write R2 minus R1. So what does it mean? That means you have to subtract this R2 element with this R1 element. But if I subtract 3 with 2, I will get 1. I will not get 0. So if I write R2 minus 3 upon 2 into R1, then see, can we get 0 here? So let's see. So here R2 means 3 minus 3 by 2. Now this R1 means this element. So if we multiply this 2, then we will get answer as 0. So now if I use this 3 by 2, then I can get 0 at this position. So this is our row transformation operation, which I will apply not only these 3 and 2, but I will apply this on 2 and 1, 3 and 1, and then 18 and 10 also. That means all the element of row number 2 has to be changed by applying this row transformation operation. But you have to take care that you have to write this operation keeping in view that this element should be made 0. I do not care about the other element values, but this element should be made 0. So now if I apply this operation, then what will I get? So row number 1 will not change. All the element will remain same. And now row number 2 has to be changed. So here I will write this will be 3 minus 3 by 2 and row 1 element is 2. So I will write 2. Now I will apply the same thing here on 2 and 1. So it will be R2 is 2. Next minus 3 by 2 into what is R1? R1 is this corresponding element. Now next element is 3 and 1. So I will write 3 minus 3 by 2 into 1. Now the same thing has to be done here. So my row 2 is over. Now row 3 will be written as such. Now here I'm not using these column. You can just treat them that they are present already. Now if I solve this matrix, what will I get? What will I get from here? So this will be 3 minus 3, 0. And from here, what I will get? 2 minus 3 by 2 into 1, I will get 0.5. From 3 minus 3 by 2 into 1, from here, I will get 1.5. And from here, 2 5s are 10, this will be 3. And the third row will remain same. So this is my matrix after applying this row transformation operation on the given original augmented matrix. So finally this element is 0 and other element of the row 2 has also been changed. Now my next motive is I have to change this one to 0. So let me copy this thing into the next page and then we will solve. So now let's make this one as 0 using this row number 1. So I have to write some row operation here and I will get a new matrix. So again we have to do the same thing. What should I subtract from this one using this row number 1 so that I should get 0 at this position. So I have to change row number 3. So I have to subtract something from R3 using R1. Now if I do 1 minus 2, that means I will get minus 1, but I need 0 here. So what I can do is I can write R3 minus 1 by 2 into R1. If I write 1 minus 1 by 2 into this 2, so here this will be cancelled and I will get 0. That means this row operation will make this 1 as 0. So let's apply the same thing. So first row will not be changed and second row will also be same. Now here I will write 1 minus 1 by 2, the row 1 element, that is 2. Same way here I will write R3 minus 1 by 2 and what is the next element, that is 1. Then I will write this 9 and 1 and lastly I will write 16 minus 10, that is 16 minus 10, but here I have to write 1 by 2 multiply. So what will I get here? So 2 are cancelled, so here I will get 0 and here I will get 4 minus 0.5, that is 3.5. Here I will get 9 minus half, that is 9 minus 0.5, that is 8.5, and here I will get 16 minus 5, that is 11. So after applying this operation, I have got this matrix. Now here you may have some confusion that while we are applying the first row operation, that is we were applying this row operation, can we not apply some another operation using R2 and R3? That means I can make this 3 as 0 using this one also. How? We can write 3 minus 3 multiply 1. That means this 3 is this 3, this one is this one, and this 3 is like a constant value. So here 3 minus 3 into 1 will be 3, it will be 0. So here I have used operation like R2 equal to R2 minus 3 into R3. So this operation is also valid, but I have said I have to use R1. So using R1, this is the valid operation, and using R3, this is the valid operation. But when we will implement this method using a C program, then we will see that we will use this row number 1 with this 3 and this one. That's why I am following the same approach so that it is easy for you to understand the C program also. So it is not necessary that the operation that I am showing here, only those row operations are valid. You can apply any other row operations also. The main thing is you have to make this 3, 1 and 4 as 0. So with this thing, let's move forward. And now we have made this element as 0. Now we have to make this 3.5 also as 0. And we will use this row number 2 to make this 3.5 as 0. So let me copy this into the next page. So now you can tell me that using 3.5 and 0.5, how we can make this 3.5 as 0. So if I write 3.5 minus 0.5, I will not get 0, but I can use some constant here, or you can say some ratio here, so that if I multiply that thing with this 0.5, I can get final answer as 0. So if you observe carefully, then what you can write here, you can write 3.5 divided by 0.5. And what is this 3.5 upon 0.5? This is actually 7. So it means 3.5 minus 7 multiply 0.5. And this is actually 3.5. So 3.5 minus 3.5 will be 0. So I can say, I can write R3 as R3 has to be changed. R3 minus 3.5 upon 0.5 multiply R2. So row number 1 and row number 2 will not get changed. So I have copied them as such. Now this 3.5 upon 0.5 was actually 7. So I can simply say this is R3 minus 7 into R2. Now what will come here? So here we can see here is 0 and here is 0. So this R3 minus 7 multiply this R2 element is 0. So you will see this 0 minus 7 into 0 will come as 0. That means this 0 is not getting changed, and we want this also. That is, this should be 0 and this should be 0. If we apply wrong operation and if we make this 0 as some non-zero value, then our whole previous work will get wasted, because we do not want to change this 0 to any non-zero value again. So you have to be very careful that which row operations you are actually applying. Now let's move to this 3.5. So if I write 3.5 minus, here I will get 7 multiply then this 0.5, and here I will write 8.5 and 1.5, and lastly I will use 11 and 3. So now if I solve this, I will get a new matrix. So now let's write this row. So this row will be 0. Now what will I get from here? So this will again be 0. So if I solve this, what will I get? I will get minus 2 from here. And from here, I will get minus 10. So if you now see that I have got all these three elements as 0, that means this is actually my upper triangular matrix. That means I have completed the second step. So that is, I have completed the second step. Now before moving to the third step, that is, we have to apply the back substitution method. We have to check one thing. So if you come here at the first row operation, so here you have taken this as 3 by 2 here. So how does this 3 by 2 came? So this is actually like you are changing this row 2 using the row 1. So you have used this 3 in the numerator and this 2 in the denominator. That's why this came as 3 by 2. So this is actually ratio. The same way you have used 1 by 2 in the second row operation. So how this 1 by 2 came? So this R3 has to be changed using this R1, and in the similar manner here you have written this as the ratio. So here you changed this row using this row. So you wrote that 3 by 2 divided by this 0.5. So this way this ratio is coming. So this will be very useful when we will implement this using a C program. Now let's say if you have the 4 linear equation, then your augmented matrix will be like 4 rows and 5 columns. Then in that case, you have to make all these elements as 0, because they are actually below the diagonal. So in that case, while you are making these three elements as 0, you will take the help of row 1. While you are making this element as 0, you will take the help of row 2. And while you are making this element as 0, you will take the help of this previous row. So this pattern you should know because it will be very useful when you will implement this using a C program also, and when you are solving the questions also in the theory. So now let's take this upper triangular matrix and apply the third step, that is back substitution method. Now to apply the back substitution, we have to convert this matrix into the linear equations. And how we can convert that? Because these are the coefficients and these are the actually constants. So again, we have to convert these into the form of like x and y and z. So we have to write 2x plus this is y and plus the coefficient is 1. So we can simply say z equal to 10. In the similar manner, this is 0. So this is like 0x plus 0.5 into y plus this will be 1.5 into z and equal to 3. And accordingly, we can write the third row. So here we can see this coefficient is 0. So this 0x actually can be removed. The same way, these two are 0. So this 0x and 0y can be removed. So we are left with these three linear equations. Now back substitution means we have to find the values of x, y and z. And how we can do that? Here we have the word back. So here we will first find the value of z, then we will find the value of y, and then we will find the value of x. And how we can do that? So here if you are given these three equations and you are asked that you have to find the value of x, y and z. So I think it will be very easy to find the value of x, y, z from these equations for yourself. So I think it will be very easy to find the value of x, y and z from these three equations for you, because we have the three equations and the three variables. And while you are finding these x, y and z, what will be the first value that you will got from these three equations? You will say you will get the value of z, because this is the third equation that you can simply solve. So you can say this will be z equal to minus 10 upon minus 2. So that will be 5. So you got the value of one variable. Now our z is done. Now you will put the value of z that you got from this equation into the previous equation. So here you will put the value of z and then you can simply find the value of y. So if I put z into this, you will get y equal to minus 9. Now you will put the value of y and you put the value of z you are getting from here into this first equation. And you can simply find the value of x. So I wrote this first equation here and I solved this and finally I got x equal to 7. So my x is 7, y is minus 9 and z is actually 5. So these are my three values of the unknown things or the unknown variables. And this is the solution of my given linear equations. That means if I put 7, minus 9, 5 values in the given linear equation, then I can satisfy all the given three linear equations. So if I put 7, minus 9, 5 here, I will get 10 from here. So you can see 7 2s are 14, 14 minus 9 plus 5. You will get 10 as the answer. So 10 equal to 0. The same way you will put 7, minus 9 and 5 here, you will get 18 as the answer. So actually it was z here. It was my mistake that it was x. In the same way, if you put 7, minus 9, 5 here, you will get 16 from here. So 16 will be equal to 16. So you applied total 3 row operations to change this augmented matrix into a upper triangular matrix. So you applied this row operation, then this row operation, and then finally this row operation. And finally you got this upper triangular matrix. And then to find the value of x, y, z, you applied the back substitution method and you got the final x, y and z. So I think now you have understood that how to apply this method to solve the system of linear equations. So now we will see the pseudocode to understand that how we can implement this method using a C program. So let's understand the pseudocode. So input in our this given program for the Gauss elimination method will be the number of unknown variables that we want to find. For example, in our given question, we have to find the value of x, y and z. So these are the unknown or the variables for which we have to find the values. So in that case, we will enter n equal to 3. And second thing is we have to enter the augmented matrix. So what does it mean and why we have taken the size of this matrix as this n plus 1. So as you know, you have to solve these linear equations. So how you will enter these equations in your program? So in programming, you have to implement these using some data structure, or you have to store all these equations in a data structure. So the 2D array, or you can say matrix, is a good way to store these linear equations. So you have stored this row, that is the coefficient of this row and this constant, in this way in the augmented matrix. And the same way each row is stored in this augmented matrix. So these are the coefficients and these are the constants. That is, these are the constant. So while you are asking the user to enter the augmented matrix, you will enter all these elements in the row form. Now if you see here we have 3 rows. So here total number of rows are 3, and what will be the columns? So here we can see there are 4 columns. So for n equal to 3, your matrix size will be 3 into 4. That is 3 into, this is 3 plus 1. Now let's say you have one more variable, let's say w. That is x, y, z and w. And then you have, let's say, 4 equations. Then what will be the size of the augmented matrix? So in that case, you will have total 4 rows and you will have actually 5 columns. So for these columns will be with respect to like x, y, z and w coefficients, and the last column will be with respect to these constants. So total, what will be the size of that augmented matrix? So it will be 4 multiply 5. That means for n equal to 4, this will be the size of the augmented matrix. That means this can be said as n, and this is n plus 1. That's why I have taken the size of the augmented matrix as n plus 1. So after entering the linear equations in the augmented matrix and asking the user how many number of unknowns are there, what is the output that you want? The output is the value of the unknowns, that is value of x, y and z. Now the question is, you do not know how many unknown variables you can find. You can find 3 variables, you can find 4 variables. So that's why you have taken a array, that is value array, which will be equal to the size of these unknowns, in which you will store the value of x, y, z, so that you can print later on. So for the case of n equal to 3, I will have the element at 0, 1, 2 position, and here x will be stored, here y will be stored, and here the value of z will be stored. So after taking the input from the user, what is the next step? The next step is we have to convert our augmented matrix into the upper triangular matrix. So this is the code to convert that into the upper triangular matrix. And after this code is over, we will have the new matrix. That is, the augmented matrix A will be changed to the upper triangular matrix. Now after we get the upper triangular matrix, we have to apply the back substitution method. So this is the code for the back substitution method. Now after this code is over, we will get the value of x, y and z in this value array. And finally, we have to print this value array. So now let's understand this code and this code step by step. So let's understand this pseudocode first. That is conversion of augmented matrix into the upper triangular matrix. So here I have written the same thing, that is augmented matrix, and how we applied the various row transformation operations, and finally we got the upper triangular matrix. So in this code, I have taken the 2 for loops, as I have to traverse this given matrix. Now inside this I have used the if, and inside this if I have find the ratio, and then inside this inner for loop I am repeatedly doing this thing. And this if is saying only when j is greater than I, then only all these operation we have to implement. So as we know, we have to convert this 3 to 0, then this 1 to 0 and this 4 to 0. So first let's see how we can convert this 3 into 0. So initially I is 0 and j is 0. So this if condition will be false. So this ratio and all will not be executed. Now again this j loop will be incremented and j will now be 1. And now j is greater than I. So we have to come inside this if block. And here one thing is to notice, we have find this ratio first, and then we have applied this row operation on all these 4 elements of this particular row. So here we will call this is row 0, this is row 1, and this is row 2. So what we will do here, for the first time, what we want the ratio as 3 by 2. So let's see, are we getting this 3 by 2? So this is 3 and this is 2. So this is 1 0 and this index is 0 0. So here if you see, we are getting this j as 1 and I is 0. So a10 divided by ai, that means a00. So this is actually 3 by 2. So that means we are getting the ratio as 3 by 2. Now what we are doing, we are taking this ratio and we are going inside this for loop, and we are repeatedly applying this thing on all these elements of this particular row. That means this particular k loop is actually applying the row operations. And so here if you see, k is starting always from 0, and how many times this k loop is running? So it is actually running n times. That is, for n equal to 3, how many times it will run? So 3 plus 1 will be 4. So this will run for 0, 1, 2, 3. That means total 4 times. And how many elements are there in each of the row? So in each of the row, there are actually 4 elements. So on all the 4 elements, we are applying this operation. So you can say that this is actually j and this is actually I. I is referring to 0 and j is referring to 1. Now here we want to apply operation on 1 0, 1 1, 1 2, 1 3. And here you see that this k is incrementing always from 0, 1, 2, 3. And this j is static. J is what? J is 1. So this will be 1, 1, 1, 1. So this will be 1 0, 1 1, 1 2 and 1 3. All these particular rows element. So here for the first time it will be 3 minus ratio will be constant, that is 3 by 2. And what is this aik? Aik is referring to the element of the ith row, that is 0th row. So here we should get as 2 because this I is 0 and k is 0. So 0 0 is 2. So here we will get this answer, that is 0. The same way when k will be equal to 1, we have to change this 2. So here we are getting j as 1, k as 1. A11. So A11 is actually this 2. So 2 minus 3 by 2 is constant into ith row, that is 0. So A0 of 1. A0 of 1 is this element, that means 1. So here we are writing 1 and this will be 0.5. That means this answer. So in the same way, we will apply this operation on all the 4 elements of the particular jth row. So after this operation, we will get this matrix. Now when again this j will be incremented, this j will be 2. That means j will now be coming here. Now j is 2. So here it means that we have to convert this 1 to 0. That means now our j is pointing to this row. So we have to convert this 1 into 0. So my I is 0 and j is 2. So I will remain here only. So again 2 is actually greater than 0. So this if will be true and I will find the ratio and apply the row operation in all the jth row elements. So here ratio should be 1 by 2. That means this 1 should be divided by 2. That means A20 should be divided by A00. So here you see this is 2, this is 0 and this is 0 0. So yes, we will got the ratio as 1 by 2. So now this ratio will be taken here and then and all the jth row element will be changed. So this jk will be actually j is 2 and k is starting from 0 to 2 0, 2 1, 2 2, 2 3 indexes element will be changed. That is this row will be changed and we have to use this row, that means ith row. So that's why here I is written and I is 0. So that means 0 0, 0 1, 0 2 and 0 3 element of the 0th row will be used and ratio will be applied in between. And finally we will get this matrix. Now after this matrix is found, now we will again increment this j loop and j will be 3. So this j loop will be now false because j is not less than n. So at last we have to increment this I loop. That is I will be 1 and j will again be starting from 0. So your I is 1 and j is 0. So if you see this is 0, this is 0. Now finally we have to make this 3.5 as 0. That means now we have to find the ratio as 7. So if you see here j is 0 and I is 1. That means j is 0 and I is actually this one. So here j is less than I. So my if will be false. Now again my j will be incremented and j will be 1. Again 1 is not less than 1. So this if will not be true. And again this j will be 2. So now 2 is greater than 1. So this if will be true. And I have to find the ratio now. So what ratio I want? I want 7. So how I got 7? 3.5 divided by this 0.5. That means the index, that means this is the 2 1 index and this is 1 1 index. Both should be divided. So this, if you see, j is 2 and I is 1. If I put it, then I will get the answer as 7 for the ratio. And if I put 7 as the ratio here, I will change what indexes? I will change this row 3 indexes. That means index 20, 21, 22 and 23 will be changed. So here j is 2 and k is 0. So that means 20, 21, 22 and 23 index will be generated and they will be changed. And I have to use this second row, or you can say the row number, you can say 1. So here I is 1. So 1 0, 1 1, 1 2 and 1 3 will be generated. That means all these elements will be generated and ratio is 7. So after applying all these things using this for loop, I will get finally this row. So that means I have got upper triangular matrix. Now if you run this loop again, then you will see that j will be again 3 and this j loop will be false. I will again run, I will be 2 and j will be like 0. But as j will never be greater than I, so this will be like j will be incremented to 1, 2 also, but this thing will not be true. That is, if will not be true. So at last, outer I loop will be false and we will come out. So finally, we have this matrix. Now we have to apply the back substitution method. So let's see the code for the back substitution method. As we have the unknown variable as 3 for our example. So what this line is doing? This line is actually finding the value of z, and this part is actually finding the value of y, and then this is finding the value of x. That means one element will be found here. Rest of the other variables, that is n minus 1 variable, will be found using these for loops. So I have taken this value array where I will store x, y, z, and this is my upper triangular matrix that I have got from the previous code. So when we have solved our example, then we have seen that we had converted this matrix into the equations again to find the value of x, y, z. But here we have the matrix in the program. So if you see, to find the value of the z, we can use these values, right? Because we have written these as minus 2z equal to 10. So z will be minus 10 upon minus 2. That means the last two values of this matrix should be divided. And what is the index of this minus 2? It is 2, 2 and index of this is 2, 3. That means for general n, it is like n minus 1, n minus 1 and it is n minus 1, n. So we are dividing this thing with this thing. The same thing we have written here. So all these two elements will be divided. That means minus 10 upon minus 2. And then we will get z equal to 5. So our z will be 5. So this is simple. Now where we have stored this z, so if n is 3, we have stored z at the last index, that is index number 2. That's why I have written n minus 1. For n equal to 3, this will be 2. Now it is up to you. You want to store the value in the form of like z, y and then x. So that will also be correct, but you have to change the code accordingly. Now here inside this for loop, we have to find this value of y and x. So first I will find the value of y and x. So from this line, I will first find the value of y and I will store that value of y at index number 1 and then I will find the value of x to store the answer at 0 index. But there is some for loop before that. We will see that. Now before that, how many times this for loop will run for n equal to 3. So you will say this 3 minus 2 will be 1, and so this loop will run 2 times. So in one iteration it will find y, and in other iteration it will find x. So let's see how we can do that. Now before moving, first I want to ask you how you have converted these equations in the x, y and z form. So this first equation was converted into this form, and to find x, I can write this in the form of like 10 minus y plus z upon 2. And finally, I can find the value of x. So to find the value of x, what I need? I need this last element, this first element of the matrix, and other thing is I need the sum of y and z. That is, I have to take the help of these coefficients plus the value of y and z. So it is like we have to find 1 into y plus 1 into z. So I will use all these coefficients and find the sum. So this is actually sum, and the same thing I have written here. This is the same sum that I am using here. So to use this sum here, I am repeatedly finding the sum in this loop. So here these are two elements. So we will see that this loop will run 2 times to find the x. So main thing we understood that we have to find this sum before finding this x. So let's see first how we can find the y. So for y, we can write this given thing in the form of equation as this way, and we can find the y as 3 minus. So here this is actually sum that we have to find. 3 and 0.5 are these things. So here if you see for I equal to 1, we will come here and this will be 2. So 2 is less than 3, yes, and this loop will actually run only once. So here you will see that this is 0 plus something multiply something. So here it will be like 1.5 multiply z. So here you can see this is 1.5 into z. So what is z? Z is this value element. So this is actually value of j, that is value of 2. So value of 2 is 5. And what is this a of ij? So at this aij, I should get 1.5. So here if you see the index of this is 1 0, 1 1, and this is 1 2. So this is 1 2. I is 1 and j is 2. So yes, I am getting 1.5. So this will be 1.5 multiply 5. It will be stored inside sum. And this for loop will not run again as it will be false. So here I got 1.5 multiply z. And now I have to divide it by aii. That means a of 1 1. What is the value of a 1 1? This is 0.5. So this is 0.5. And what should I write here? So if I see this is 3. So this is the corner element. That means some n will come. N will come means this n should be in the indexes. So ain means a13. A13 is the element 3. So after solving this, I will get value of I, that means value of 1. So this will be like 9 that I have got from the solution. So this is actually minus 9. Now the same way, I think you can find the value of x also. So this loop will again run, and now I will be decremented. I will be 0. So this 0 is getting used here also. So at 0 position, my answer will be saved. And before that, sum is again made 0. And this loop will again run from j equal to 1, because 0 plus 1 is 1. And this loop will run now 2 times. And here what I have to find? I have to find y plus z. So I think you can run this loop by yourself, and you will see that the sum of y plus z will come from this answer. So sum will be y plus z, and this sum will be put here, and you will see that you can find this equation or this answer from here. So whatever the answer will be coming, it will be saved at value 0. So this was coming as 7. So this 7 will be saved here. So finally, by this back substitution method, we have the values of x, y, z in this value array. So what is the last step? You can just print this value array to show the answer of x, y, z. So I think you have now understood that how we have implemented this solution using the pseudocode, And you can also find the relation between the mathematics and the computer science, that how beautifully computer science can implement the mathematical relations in the coding. So I would highly recommend that if you have not understood the pseudocode, you just pause the video or you rewind the video, you listen the video again, you do some rough work to understand how this code is implementing the pseudocode. So now let's understand how we will write this C program using this pseudocode to implement this Gauss elimination method in a C program. So this is our C program to implement the Gauss elimination method. So here, if you start from the main function, then you will see that inside main function, I have asked the number of unknowns from the user, and then I have asked the augmented matrix. And here I have defined the matrix A, that is augmented matrix of the size n plus 1, and the array value. So first I have scanned the value of n, then I have defined these arrays. Now inside this for loop, you are asking the user to enter the elements inside the augmented matrix, and this augmented matrix elements can be float also. So you have taken the float data type. Now after taking the augmented matrix as the input, you have to apply basically two operations before printing the value array. So first you have to convert the given augmented matrix to the upper triangular matrix. So this function convert to upper triangular function will be converting our matrix to the upper triangular. And after that you have to apply the back substitution method. So this function is doing the same thing. So it will be finding the value of x, y, and z for the case of n equal to 3, and then it will be filling all those values inside this value array. And finally our print function will be printing all the elements which are present inside this value array. So let's see the code for these functions. So this is our convert to upper triangular function. So here if you see, this is the same pseudocode that we have discussed. So two for loops are there, if condition, then we have found the ratio, and then we have implemented this k loop. Now as you know, this loop will be changing some rows of the given matrix. So what we are doing, we are printing the given changed matrix after each of the operation. So here we are printing the intermediate forms. So this is optional. If you want to print the intermediate forms for the better understanding, you can print, otherwise it is up to you. So this was our convert to upper triangular function. So it was actually accepting the matrix and the number of unknowns. So now let's see the second function, that is apply back substitution. So it is again taking the matrix that we have got from the convert upper triangular function, and it is taking the value array also so that it can store the answers, and lastly it has taken the n. So this is the same code that we have discussed. So I think there is no need to tell you again this code. So when this function will give us the value of this x, y, z inside this value array, then after that we will be printing the value array. So this print function will simply be printing this value array. So this for loop is there and we are printing the value of this value array. So this was the simple code for the implementation of the Gauss elimination method. And now let's run this program and check the output. So how many number of unknowns are there? So we will be entering the same example that we have discussed. That is, we have unknowns 3, x, y, and z. And now we have to enter the augmented matrix. So here I have entered the augmented matrix that we have discussed. So now let's run this. So after entering the augmented matrix, this is the output. So here you can see we have got some intermediate forms, and finally we have the value of unknowns as 7, -9, and 5. So in intermediate forms, you can see this is 0, then after that this is 0 and this is 0, and finally our this element is also 0, and at last we have printed the value of the unknowns, that is x, y, z, using the value array. Now you can take other equations also and you can test this program on those equations also. You will get the right answer. So I think you have understood that how to apply the Gauss elimination method on given set of equations, and you have also understood that how to implement this using the C program. So if you have any comment, query, or suggestion, that you can write into the comment box, I will answer them. You can also watch my other videos related to C programming, interview question, lead code solutions, and so on my channel. I have also made the video on the other numerical methods like regular falsi, bisection, secant method, and so on. So you can watch them also. See you in the next video. Till then, goodbye.